come to this section with error sanctioning and training and optimization. Based on the kind of output we have, we're going to use the categorical cross entropy loss, which we've defined already and throughout this course. So there we go, we have our CCE loss. Also, one of the most prominent performance measurement metrics for question answering is the F1 score, which is defined as 2 times the precision times recall divided by precision plus recall plus an epsilon. That's a very small number to avoid having an infinite output when the numerator is far greater than the denominator. We define the F1 score right here. We have the precision, we have the recall, and then we simply apply the formula we had in the slides with the value for epsilon fixed at this, and then we return the F1 score. So we'll run this, and then again here we have our categorical cross entropy loss, which we could run, and then we have this checkpoint right here. We'll specify the metrics F1 score, which is this function right here, and then we're ready to train our model. So we'll just run this. We have the model trained quite well. We could now take this off so we train faster. So we go to graph mode, and then we take off the metrics for now. So let's interrupt that, run this again, and that's fine. After going training for around 360 epochs, we have these results. You can see right here. Now what we could do is we could now include let's now include the F1 score and see the kind of F1 score values we're getting. So there we go, we have this results. We see that the F1 scores for the head start and then the head end are actually the same, although that of the head end are coming out to be better. Now we should let's just test our model and see the kind of results we obtain based on this F1 scores right here. Now, considering this context, which is part of the data set, we have this question: when was Beyonce born? Where we take in the input, as we take in the context, we take in the question, we map this with a vectorized layer. Then we have this input 1, input 2, which we pass into the model. Obviously our model takes in the 2 inputs, so we have input 1, input 2. From this we collect the output 1, and then from the end we collect the output 2. Based on this start and this end, we now have to go through go through this context and then locate the words by doing this. So we've gone with this, we actually split the context. Don't forget to pre-process this. Then we pick out only the words which fall under this indices right here, which fall between start and end. So once we have this, now we simply print this out. So let's run this, and we have the following results. That's it picks out from the 1990s instead, so it actually predicts this very wrongly. Now this is because this question actually is not part of the data set, so our model is kind of overfitting to this 1,000 data points. Recall that we're working with 1,000 data points instead of the whole data set, which is more than 80,000 data points. Anyway, let's use this question which comes from the data set. Put out this question right here, and then we run it now, and this is the answer we get: Houston and Texas. Although the correct answer is actually Houston, Texas. So we have this is the correct answer. All this others weren't actually relevant for this. So we could say our model actually partially understands this. Nonetheless, to have the best results, it suffices to train with all the data points so that you could now test on different kind of examples while having great results. Now let's take some other example. Suppose we say we have this context: my name is Jason and I grew up in Boston. So we have that. In what city, or let's just say, where did I grow up, or what's my name? What's my name? So run this. We see that again here the model struggles to get the right answer. It says, when we say what's my name, we have it's Jason and I grew. So actually the model does this correctly but not perfectly, since we also have this parts which were not necessary.